What if I told you that cattle could be part of a climate solution? That's interesting, right? Well, it's true, and it's because of how methane works. Let me explain. Cattle emit methane, which is a strong greenhouse gas. And we need to make sure we're not emitting more methane. But if we can decrease it, then good things can happen. Methane is a greenhouse gas emitted from various sources. There's fossil fuel extraction, wetlands, and ruminant animals. When we measure methane's impact on the climate, we do so by comparing it to carbon dioxide, which is the most abundant greenhouse gas in our atmosphere. But the way we've been comparing the two climate pollutants doesn't reflect how they warm the planet. And if we're talking about a warming climate, then we should measure greenhouse gases by how they warm, right?
If your question is, how do we reduce warming? Then the answer is yes, we have been looking at methane incorrectly. We want to know what the impact of a methane reduction is on warming. And for that, CO2 equivalence is a totally wrong unit.
Current standards say 1 molecule of methane is as strong as 28 molecules of carbon dioxide over 100 years. And that's true. But methane doesn't live for 100 years. It's a short-lived climate pollutant, staying in our atmosphere for about 10 years before it's destroyed, meaning it's not causing warming for hundreds of years. Carbon dioxide stays in our atmosphere for 1,000 years, building up and continuing to warm long after it's emitted. Methane from cattle is also part of the biogenic carbon cycle, which has been around since life began. As part of photosynthesis, plants capture carbon dioxide from the atmosphere, absorbing the carbon and releasing the oxygen. That carbon is converted into carbohydrates in the plant, which is then consumed by a cow where it's digested and released from the cow as methane. After 10 years in the atmosphere, that methane is broken down and converted back into carbon dioxide. These carbon molecules are the same carbon molecules that were in the plant the animal ate, which was pulled from the atmosphere by the plant and is now back in the atmosphere. It's recycled carbon.
Biogenic carbon is different because it's going through a cycle. That's very different from fossil carbon, which goes through a one-way street from the bottom up into the air. If we were to keep our herd size constant, then that would mean that the amount of methane produced by our livestock and the amount of methane destroyed balancing each other out, meaning no additional carbon added to the atmosphere, and that means no additional warming.
Methane from cattle is considered a flow gas because as it is emitted, it is destroyed. Conversely, carbon dioxide from fossil fuels is a stock gas, which means it's stockpiling, or in other words, building up in the atmosphere. Carbon dioxide emitted today is added to the carbon dioxide emitted yesterday, which was added to the carbon dioxide the day before, and so on. This isn't a cycle. It's a one-way source of warming. The good news is, if we manage to reduce methane from cattle, such as with feed additives or digesters, we can actually generate short-term cooling. This is significant as we try to keep global temperatures from rising past 1.5 degrees Celsius.
What gets me the most excited is that if we reduce methane from, let's say, cattle, then we are actively pulling carbon out of the atmosphere. That's almost as if you were to store atmospheric CO2 in the ground. If you reduce methane from cattle, you pull carbon out of the atmosphere, and that induces global cooling. Can it be done? It can be done, and it has been done. Here in California, for example, we have been able to reduce methane by 25%. The way we reduce this 25% methane in California is through manure management changes. If you reduce methane, you induce a strong cooling effect. So meaning cattle be an important part of the solution to reduce our overall impact on climate.
Rethinking methane allows us to focus on climate solutions, both in the short term and long term, while still working to feed a growing population. But it'll take farmers and ranchers, regulators, and researchers working together to do so.